This is a training video for the Lake Champlain Committee Volunteer Blue-Green Algae Monitoring Program. In this video, we'll go through what are blue-green algae, why we monitor for them, and what are the protocols for being a volunteer blue-green algae monitor for the Lake Champlain Committee. Blue-green algae, also known as cyanobacteria, are a wide group of organisms, including freshwater, saltwater, and terrestrial species. They are many different types of them. It's a group of organisms rather than just one thing. Under certain conditions, these organisms can create extensive and unsightly blooms that can be a potential health hazard. Blooms are most likely to occur in conditions with high nutrient levels. In freshwater systems, we focus particularly on phosphorus, though nitrogen also plays an important role. High temperatures lead to blooms. Once the nutrient levels are there, then high temperatures will trigger the organisms to reproduce, and calm weather helps promote the blooms as well. As the weather is there's more turbulence, if there's waves and wind, then the organisms get shifted into the water below and don't reproduce as well, and blooms are more difficult to form. So once you have the high nutrient conditions in the water, then a spate of hot, sunny days is when blooms are most likely to occur. And on those hot, sunny days, they can show up pretty much anywhere on the lake. In particular, we worry about blue-green algae because some species, under some conditions, produce toxins. There are 5 different types of cyanobacteria blue-green algae toxins, 2 of which are of particular concern on Lake Champlain: microcystins and anatoxins. Microcystins are liver toxins. There's a lag between exposure to these and any symptoms that might show up. Anatoxins are nerve toxins, so symptoms show up within minutes or hours of exposure. For an adult human, for both of these symptoms of exposure might be nausea, vomiting, diarrhea. If you're exposed to aerosols, then it could include runny nose, watery eyes, sore throats. The nausea, vomiting sorts of symptoms are similar to what you might have at a sunny day at the beach, or having too many beers, or eating a bad potato salad. They're non-specific and often attributed to things other than blue-green algae. So we don't get a lot of reports of human illness associated with these toxins. Folks just deal with the symptoms and then go on. But we do know that toxins can cause symptoms under certain conditions. Small children are most at risk because of their smaller body size, so that a similar dose would have a greater impact on the smaller individual, and also because they are often playing in sand. They're more likely to play in sand where blooms might occur. Dogs also have been taken ill from toxins, and occasionally we've had dog deaths, which has really stirred some of the interest in blue-green algae on Lake Champlain. Dog deaths have been associated with anatoxins in the past. We have not seen a dog death on Lake Champlain since 2003, and we haven't even measured anatoxins on the lake in the last few years, at least. Microcystins we do measure every year on the lake. In addition to these, there's a 6th potential neurotoxin, called BMAA. This is a highly controversial. It's not well established in the literature that there actually are impacts from this, but there are some people that believe BMAA causes neurodegenerative diseases, including ALS, Alzheimer's disease, and Parkinson's. That link is not well established, and any time between exposure and actual symptoms is quite long. It's not considered something of short-term consequences. The behavioral changes resulting from BMAA or any other algae toxins are the same. We always presume that blooms produce toxins and should generally be avoided. Dogs in particular are vulnerable in part because they are smaller, because they will swim in waters that other people won't, and because when they leave the water they're likely to lick their fur. This last year's blue-green algae monitoring program trained over 300 volunteers. Not all of them went on to volunteer, but that became 300 people that had an idea of what they were looking at on the lake. We received almost 1,500 reports during the 14-week monitoring period. Our regular season lasted from June 13th to September 18th, and we had 100 sites that reported regularly, which means more than 6 times per year. Those regularly reporting sites we can use for long-term record keeping to see changes in blue-green algae frequency and duration over the season. season. So if we do monitor, we ask that you provide us at least those 6 reports over 6 weeks during the summer period. Here are the results that we had from 2015 from our regularly reporting sites. Each bar represents a different lake segment or different lake. The number in the box at the top of each bar is the number of sites within that lake segment. The blue area are observations of no blue-green algae at all. Yellow is some blue-green algae present, and red is high degree of blue-green algae. The takeaway message from this graph is that blooms are fairly rare on the lake. Over 95% of our regular observers did not report seeing blooms at all, and then less than 5% saw blooms. When blooms occur, they tend to be highly concentrated in certain lake segments, in particular St. Albans Bay and Missisquoi Bay, where nutrient levels are much higher. They do occur in other places, but much less often than in those 2 bays. This is the same data, but spread out over time now. Each bar represents 1 week, and the take-home message from this graph is that the blooms occur later in the season, July, August. They're not there early in the summer, in June so much. Also, a takeaway message is that our monitors start to drop off come September. They go back to school, they leave their lake homes, they go back to other jobs, but the blooms can persist beyond that period in time. Our program is designed to guide recreational use. Recreational use drops off in the fall, but the blooms are still there. These data are the data from our monitoring program over time from 2012 to 2015. Each graph represents a different lake segment, and what you can see here is that the results from 2015 were not substantially different from years past. We've seen an overall increase in the number of monitors, but we haven't seen a dramatic shift in the numbers of blooms occurring. So we're hoping that people watching this video will become blue-green algae monitors for the lake. And what's involved with monitoring is watching this video, taking this training, observe the water at least once each week, and then share your observations. Share them with your neighbors, but more importantly, fill in an online form so that we can use the data you're gathering. And that's it. We try to keep the program simple so as many people as possible can be involved. When you go down to the water, we're really looking for observations for you to categorize it in one of these 3 ways. Either there's little or no blue-green algae present and your enjoyment of the water is not impaired, there's some blue-green algae present and enjoyment of the water is slightly impaired, or there's extensive blue-green algae present and enjoyment of the water is substantially impaired. A few other protocols. Ideally, monitors would be consistent week to week regarding what day and what time you monitor. The reason for that is we don't want folks going out and just choosing to monitor when conditions are good or when conditions are bad. If you pick a regular set time that you can go out, then that provides us more consistent data. That doesn't mean if you have a doctor's appointment or some other reason that you can't do it on your regular week that you can't shift to another day. We're just really asking monitors not to choose good or bad conditions. And then we want the observations ideally between 10 a.m. and 3 p.m. The 10 a.m. start period is because the blue-green algae can regulate their position within the water column. They will float towards the surface as the sun comes out, and so observations that are too early in the morning may not be capturing how much is actually there. The 3 p.m. time period is a little more arbitrary. At some point they will sink down in the water column, so we want to capture it before the sun starts getting too down in the sky. All the observations that we receive through the Lake Champlain Committee are entered into an online database maintained by the Vermont Department of Health, and throughout the summer the observations are visible to any member of the public that wants to see it. This is one of the most visited resources that is there at the Vermont Department of Health, so people really are paying attention to the data that our monitors collect. So the categories of blooms. Here's some photographs and descriptions of what you're actually looking for. We break Category 1 into different subcategories. That's for the utility of the monitors, not so much for the utility of our data collection. There are a lot of other things out there besides blue-green algae that people might see, and what we want you to do is assume you're not looking at blue-green algae and then walk yourself into it that it might be something else. So the first subcategory that we have is 1A, clear water. It's what many of our monitors see all summer. It's the typical condition on the lake. But there are many times when the water is not clear, where it's really brown, tea-colored, turbid. This does not represent a health risk from blue-green algae. It's just sediment in the water, and so we created a different subcategory so you can record that it's not quite as beautiful as you'd like to see, but we're not talking about blue-green algae being there. So that's 1B, brown and turbid. 1C can be a difficult category. That's when there are other plants out there. In this photograph, there are native species, there are non-native species, and then there's duckweed. All of these are plants that you might encounter on the lake. None of them produce toxins, so they don't warrant being recorded as a blue-green algae bloom. So how can you tell the difference between these plants and the blue-green algae that we're actually concerned about? First, if you can pick the stuff up on a stick, it's not blue-green algae. It's not the stuff that we're worried about. The blue-green algae are microscopic and planktonic, the ones that we're concerned about, and anything that's hanging off of a stick is too big to be the blue-green algae. Second, if it is attached to anything, if it's attached to rocks, if it's attached to a dock, it's not blue-green algae. It's some other sort of algae, some other sort of plant, but the stuff that we're worried about is floating in the water column. Duckweed can present a bit of a problem. It is green like blue-green algae. It acts on the water like blue-green algae, but as you get closer, you'll notice that there are individual particles, individual plants here that you can see with your naked eye. They're starting to show up a little bit as you get closer here, and by the time you get really close, they're definitely there. Duckweed, you can fit a number of these onto a fingernail. Compared to the blue-green algae individuals, that's huge. These are also flattened with a distinct shape. The blue-green algae particles that we see, the largest that you would see is about the size of a pinhead, and that's fuzzy, and it's usually an agglomeration of a bunch of different individuals, whereas these duckweed leaves are clearly individuals themselves. Pollen can present a particular challenge. Like blue-green algae, the individual pollen particles are microscopic. They float on the water in the same way. There are two key things to consider with pollen. First is color. Pollen manifests as yellow. It's usually pine pollen is yellow. Blue-green algae might be blue, might be green, might be red even at times, but it doesn't really show up as yellow. And the second is season. Pollen is most common in late May, early June, and not likely to occur later in the season. Meanwhile, blue-green algae is more likely to occur as you get into August and July. Reports of blue-green algae in May lead to skepticism, whereas reports of pollen in August lead to skepticism. So color and timing are the two things to think about between pollen and blue-green algae. Pollen isn't always as extensive as the previous picture. It can show up just as rows along the water's edge as well. And then we have a category of 1D, where there's a little bit of blue-green algae present, but really not enough for people to be concerned about recreating in it. These two photographs are from the same place at the same time. On the left, the water looks perfectly fine and crystal clear, but a sample taken in a jar shows that there actually are some blue-green algae there. The monitor at this position felt that they were not afraid to go recreating in that water, even with those little dots, so we offered the category of 1D. Here's the flip side of that. On the left we have you can see the green spots in the water. There's not a ton of them. And you take a sample in a jar and it seems like there's almost none of them. So again, the monitor chose to say 1D. I would still go recreating here. There's not enough here to make me nervous. But at some point there are enough of those little green dots that it really does seem like there's something in there and maybe you want to hesitate about going into it. At this point, for a category 2, if you were to put anything into the water, you wouldn't have to actually move the blue-green algae out of the way to get it in. The typical condition for this situation is a thin line of green scum along the shore, but further out the water looks fairly clear. Those conditions we put in as category 2. When the blooms get so extensive that you actually have to move them out of the way in order to put anything into the water, we consider that a category 3. At category 3, the Vermont Department of Health recommends that beaches be closed and not reopened until water testing shows that there were no toxins or are no toxins in the water. These blooms can be quite extensive. This is a subjective program. It's sometimes difficult to figure out what category you're actually in. Here we don't quite have the entire water surface covered. I would probably categorize this as a 3, but the case could be made that it was a 2. In these situations, photographs can help us help you decide what's going on. For any photograph, we ask that you somehow identify where and when the photo was taken, either with a time date stamp on the camera or by holding a piece of paper in the view. And then we look for 3 photos. One, a close-up that we don't have pictured here. The second, a wide-angle shot so that we get a sense of how extensive the bloom is. And then the third is a sample in a jar. The sample in the jar gives us a really good sense of color, and it also helps you watch behaviors of blue-green algae. If you take that sample and just leave it in the sunshine for a half hour or so, blue-green algae will rise to the surface to start competing for the light at the top, and that's a pretty good hint that what you're looking at actually is blue-green algae. When taking a sample, you want to be about in water that's knee-deep or so. You can get that by going off of a dock or wading in. Invert the container before submerging so that you're getting a representative piece of the water column rather than just skimming off the surface scum. And then once it's underwater, tip the container to fill it. Recall that algae can produce toxins. In addition to the microcystins and anatoxins, they do have polysaccharides on their cell coats that can irritate the skin and cause itching. So in order to protect yourself, you can wear gloves, and please wash those gloves afterwards so the toxins don't dry onto it. And if any monitor is ever uncomfortable about taking a sample, this is a purely voluntary program. We can't force you to do it. We'll do our best to make a judgment without those photographs, without those samples. Data that are collected are entered into the tracker, the Vermont Department of Health tracker, via a website link. And for monitors that sign up with us, we will provide a username, a password, and links to the monitoring site, to the web login site. You'll get to the site, you'll get a sign-in page here, you enter your username and password, and then you can zoom to your site. You can zoom to the site by entering either the site number, which will also be provided to you, or entering a town name and getting close to it. Once you get to your site, then all of our regular monitors have site numbers associated with them. This one is site number 57, Sandbar State Park. You add a new report by clicking on the new report button, bring it over to the crosshairs here, and clicking to create a new dot. Once you create that new dot, a data entry form will show up. You can enlarge it here so that it's easier to see. And there's a sense of what it looks like. And here's a blow-up of it. We ask you to enter your lake. That will usually be Lake Champlain, but we also have data from Lake Carmine, Lake Elmore, Lake Iroquois. The region, we will provide that information to you in the email, but that's basically North Lake, South Lake. We'll give that information for regular sites. Municipality that you're in, site number, which is provided to you, station name, which we'll provide to you, and then report type. Most of our monitors will report just regular reports, but in some situations you might see a bloom that's not at your regular reporting site or at a different time, and then you can categorize that as a supplemental report, which will require you to fill in a little more information. The date that you take your observation, the time, your assessment method, which for all of our monitors is visual, the bloom intensity, which is those categories we just talked over, and there's a link to photo documentation similar to this website if you need to review those. If you're able to get it, we like to get water temperature. Water surface is just asking if the water you were looking at was calm, rolling, or had whitecaps, and then you can provide any additional details here, how extensive it was, if you're in a supplemental site, where it was, such like that. Affiliation would be Lake Champlain Committee Volunteer, and then your name, and you can browse and you can include attachments by browsing to where it is in your computer or camera or wherever you've taken the photo. And then hit the submit button. Once the report is submitted, you should get a thank you, a confirmation report that it has gone on, and then those reports are reviewed within 24 hours and then go live on the Department of Health website. For supplemental reports, you do not need to enter a site number or station, but you do need to include additional details to let us know where that supplemental report was coming from. Here is the public viewer as it appears during the summer. You can see the green dots are places where we had observations. Yellow dots were areas of a little bit of bloom present, and then red dots concentrated here in St. Albans Bay are where extensive blooms were. Once an observation is approved for the website, it will stay there for 2 weeks unless a more recent observation replaces it. So if you see a bloom and then it goes away, submit a new observation that tells us that it's gone away so that the dot color will change. In the event that you have trouble accessing the Vermont Department of Health tracker, then we have on our website, the Lake Champlain Committee website, a backup form that can also be used for the same data entry. And so here are just some more photos of additional situations, and ask folks to figure out for yourselves what category they might be. This is a 1A situation. Category 3. This is a 1B situation. Notice the water is all brown, uniformly brown, but a sample taken shows absolutely nothing in it. As a monitor, you'll get accustomed to your site, and this is a place where the water regularly shows up as brown and turbid. A typical Category 2 situation. A Category 3 situation with the algae starting to show this bluish sheen, fairly widespread. This, from our perspective, is a difficult picture to figure out. It's probably a Category 2, depending on how extensive it is. In a situation where we're not sure, we will defer to the judgment of the monitor in the field. The case could be made, if this area looks a lot like this over a much broader area, that it could be a Category 3. There's definitely something there, but whether it's a 2 or a 3 is we're going to defer to the monitor in the field. This is probably a Category 2. There are a few streaks of green algae in near the dock, but the broader lake water is open. If the monitor submitted a report of a 1D on this, we might accept that as well, but there's enough of a green there that we'd think it's of a 2. And this is another classic Category 2 situation. Category 1, there's no algae visible in this photo, but at the same location you can see these little green dots showing up, so that would be a Category 2. For beach managers, for Category 1, no action is needed. For Category 2, you might want to start alerting the people using the beach that there are algae present. They may have concerns about that, and then continual visual monitoring of the system. Closure is recommended if the bloom intensity reaches Category 3, then submit a water sample for toxin testing to the Vermont Department of Health, and as long as microcystin levels come back at under 6 micrograms per liter, then the beach can be reopened. If you have any further questions, please feel free to get in touch with the Lake Champlain Committee. I'm Mike Winslow, the staff scientist, and you can also email me or the organization. If you have questions, please direct them to me at the Lake Champlain Committee, and we'll see if we can solve them. Thank you for your time, and we hope that you don't see any algae on your lake this summer.